One way that we can express what's in a compound is to use something called percent composition. Now, normally when we look at a compound, we want its chemical formula, and that tells us the ratio of atoms that are in the compound. But sometimes it's handy to know the ratio of masses. So where we have been dealing with a ratio of numbers of particles, for this lesson we're going to turn around and deal with a ratio of numbers of grams. So whenever we're dealing with percent composition, that's all about grams or AMUs, but anyway, it's about mass. So what I want to show you today is how to just take the chemical formula for a substance and figure out what the percent composition is, even if you don't have a sample that's been analyzed. So let's look at something like sulfur hexafluoride. And the reason that I'm putting the names on the board is I think this is a good time in the year when we can go back and review how to make formulas from names, because we haven't done that in a little while, and that's kind of important. So this obviously is a molecular compound, and I know that because it's got a prefix in it, and anytime I see a prefix in the name, then I know it's a molecular compound. So I know I don't have to worry about charges, and it's much easier to write the formula for this if I don't have to worry about charges. So sulfur is S, hexa means 6, and fluoride would be F, so that means we've got 6 fluoride. So there's sulfur hexafluoride. So let's look at masses then. We don't even need to worry about the size of the sample, because as a percentage, if you only have one molecule of this stuff, it would have the same percentage of each compound as if you had a bazillion molecules of it. It doesn't matter if you have a ton of it or if you have one molecule, the percentage is going to stay the same. So we can very easily figure this out just looking at individual atoms, because we know the masses of those atoms because we have the periodic table, which tells us the masses of those atoms. So if you look at your periodic table, you will see that sulfur has a mass of 32 AMUs. And fluoride has a mass of 19 AMUs. And those both would be 0.0, by the way, I just didn't write that in. Now we've got 6 fluorides, so we'll have to take 19 times 6, and that's 114. So if we had just one atom, the total for this would be 32 plus 114, that's 146 AMUs. And you are familiar with percent, so you know how to do this. If we looked at sulfur, we would say the percentage of sulfur then is 32 over the total of 146 times 100. And for fluorine, it would be 114 over 146 times 100. And if we did it right, we should add up to 100%. So 32 over 146. So that's 21.9. 22 probably would have been close enough. And 114 over 146 is 78.1. Now, given that I only really have 2 significant figures to deal with here, well, that's not true because they were 0.0. Never mind. We'll leave those as 3 significant figures. And do a little sanity check and make sure that those do indeed add up to 100%. Now, you notice that the number on the bottom always has to be the total, and that the number on the top will not be the individual fluoride atoms, it will be all the fluoride atoms total. And if you do that, then you should be able to get a percentage. Let's try another example here. We'll do calcium sulfate. So that's got three elements in it. So now this one is an ionic compound. And how do I know that? Just by looking at the name. There's 2 clues that I have. First off, I still remember my polyatomic ions. Do you still remember your polyatomic ions? And I recognize that sulfate is one of those. But the other thing is there's no prefixes. And if I see a name with no prefixes, I automatically know that I have an ionic compound, and I do have to think about charges. So I'm going to run through that with you just as a review in case you've forgotten. You'll be doing some of these on your homework. So calcium is Ca. I look at the periodic table and I see that calcium is in the second column from the left. It's in column 2A. And way back we learned that all of those have a charge of +2. So that has a 2+ charge on it. Sulfate, like I said, is a polyatomic ion. So if you've forgotten it, you just have to pull out your notes and look at that again. That is SO4 with a -2 charge on it. So it turns out that because they have the same charge, you remember that crisscrossing thing we used to do? So this would be a 2 and that would be a 2, and we want the lowest whole number ratio. They have the same charge, and so we can represent them with a 1-to-1 ratio. So this becomes calcium sulfate, CaSO4. All right, so let's look at each of these individually. So calcium, if you look that up in your periodic table, you're going to see that that's 40.1 to be exact. Sulfur, we just said, was 32. Oxygen is 16 times 4, because there's 4 oxygens. Remember that that 4 only goes with that oxygen. It doesn't go with anything else. If I wanted it to go with something else, I would need to have some parentheses in there somewhere. All right, so 16 times 4 is 64. All right, so adding those all up together, and that should be 0.0, sorry about that. So I'll have 1, 4, 6, 6. Hopefully I added that together right, and that gives us a total of 136.1 AMUs. So for each individual formula unit, remember formula units? So these don't form molecules, but when we represent them with the lowest whole number ratio of ions, that becomes a formula unit. So each individual formula unit has this many AMUs in it. So as a percentage, I want to represent each element. So calcium is the 40.1 divided by the total times 100. Sulfur is 32.0 divided by the total times 100. Oxygen is, now we need all the oxygen, remember, divided by the total times 100. And if I did my math right, that should come out to total 100%. It's 40 over 136.1. 29.5%. Now I do have to round these off. So sometimes it doesn't come out to exactly 100 because of that rounding. 32 over 136.1. 23.5. And 64. $47.0. All right, let's see if that comes out. 29.5 plus 23.5 plus 47. Yes, indeed. It's always a good sign. So again, no matter what size sample you have, whether it's only one formula unit or whether it's a ton of the stuff, this would have the same percentage by mass of these different elements. So this is a new skill that we will be working on in this section.